So developing real-world BI outputs with our Redshift database. I'm using Power BI, which is a product by Microsoft, but this really isn't a demo of Power BI. I want it to be a demo of a real-world scenario for an Amazon Redshift-based output. Now, we established before that Microsoft Power BI uses its own data connector, but it still asks me for that endpoint and then the actual database that I'm connecting to. And username and password, which you don't see me enter here, but I had cached away. The demo I'm about to do here would work with Power BI or really any modern BI production tool, such as Tableau. The point being that once you establish a connection and select several tables, Redshift can deliver a significant amount of data in really rapid turnaround. So the data we're going to work with is the dim date, dim product, and fact sales. For a real simple demonstration, I'm going to create a report that shows sale of product broken down by month in terms of total sales, how individual products stack up month to month. Now you can see Power BI has deduced those relationships from our own Redshift schema. This saves us a lot of work on the data development end. So another reason why, even though those constraints may not enforce anything, they are actually still very valuable. And I'll take this as another opportunity to plug, they do help performance also. So I'm just going to do a simple stacked report. Having been in data technologies for a good 20-some years now, I'm kind of amazed at how easy it is to deliver really flashy BI these days. All I got to do is expand each of these three tables and select the data element I want. Power BI knows which ones are summable, how they're connected through relationships, and right away creates a pretty useful graphic. Now we have so many products, it's maybe not as useful as it could be, so I'm going to go ahead and jump over here to my filter and maybe drop it down to, I don't know, 6, 7, 8, 9 individual product names. Now all of this data is real-time from Redshift. So you can see the response time on those Redshift returns is really snappy. It would be easy to forget that we're working with millions of rows of data here. All right, so now that we got it reduced down to just a handful of products, each product is represented by a color. We got months going across the bottom, sales in the millions going up the left-hand side, and then the individual product names as shown here by the legend. All those numbers you're seeing on the legend are aggregate over the lifetime and the lifespan of that product. And this is the true beauty of data viz. For example, right away we can see for some reason October just isn't a very good sales month for us. Meanwhile, May, we do really well in May. This could lead to some interesting research on why that is. And all of this was produced immediately in just an ad hoc fashion. We already talked about the type of query that gets passed back and forth across either the ODBC or JDBC driver, but as we haven't written any of these queries ourselves, how exactly is it getting passed to Redshift? Well, we can dig in a little bit deeper here, and it shows the exact data that it's queried out, and then Power BI has kind of its own pseudo-SQL query language here, where it makes declarations and identifies each table and each column that we're using. We see one for product, one for sales, and we could also highlight one for dim date. But this isn't necessarily very helpful to us, but don't forget we can switch back over to our cluster, bring up our query history, and see what Power BI has been sending on our behalf. As you can see in just here a matter of a couple of minutes, it sent quite a number of different queries. Namely this one here at the very top, if we dig in, the actual query that was generated by Power BI and then passed across that data connector shows up at Redshift in this form. Pretty extensive query with a couple of subqueries and group by and filters. Not something that's very trivial. Now the database developer in me looks at this query and says, man, maybe not necessarily the way that I would write it. Not a big fan of inline subqueries. At the same time, though, it's hard to argue with the results. Working with as much data as we are and getting those rapid returns on live interactions with data is pretty impressive. All right, let's do one more demo and maybe write a query ourselves that we would pass through a BI client.